Hey everybody! Okay, so in this video, we're going to look at 8-bit encryption and see if we can understand why 8-bit encryption isn't going to pass muster as far as keeping data secure in an online environment. So as a quick recap from the last video, when you're using 8-bit encryption, that means you only have 2 to the 8th or 256 possible codes to use. Everything from 000000000, that would be the smallest, I guess, up to 11111111, that would be the biggest. Okay, so as an example, 10110111. There's 8 characters, 8 bits, each of which is a 1 or a 0. And let's suppose, you've encrypted something and it's been encrypted as that, and you're trying to crack it. I mean, this is why we have online security, because people are always trying to crack into your stuff. And I'm not going to get crazy into the computer science end of this. I just want to look at the security, the security of various systems. 8-bit, we'll look at 16-bit, 32-bit, and we'll keep going. So in other words, how long would it take a computer hacker to be able to figure out that sequence of 8 bits? That particular one, 10110111. Now, if they're able to figure out something about the logic of encryption, and encryption is pretty awesome, and it's not part of Math 105, unfortunately. However, it's a pretty rad rabbit hole to go down if you're interested. I don't want to talk about that rabbit hole right now as much as I want to look at what computers do to crack codes like that. And very often what they do is something called brute force. Now, brute force is pretty straightforward. It starts, or the computer starts with the smallest possibility for an 8-bit code. So 00000000. They try that. They see if it works. If it does, it works. If it doesn't, they try the next one, 00000001. They try that. If it works, it works. If it doesn't, they keep going. They keep going either until they hit the code or they run out of codes to try. Assuming that the code is in the 256, they'll find it eventually. It might take all the way until the last one to find it, but they'll find it eventually. What I'm going to do right now is I'm going to treat myself as a computer, and I'm going to actually see, I'm going to use my stopwatch here real quick. I'm going to see how long it takes me to actually, how would it pretend to enter 8 numbers on a computer. And then we're just going to time it. Let me try it here. 00000000. Okay, that took about 5 seconds. Okay, about 5 seconds. Now, all zeros is easy. Eventually, I'm going to have to be trying things like 0, 1, like that. 1, 0, 1, 1, 0. So let's make it 10 seconds. Let's say Sean, the computer, can test a code every 10 seconds. How long will it take Sean to test all of those 256 codes? All right, well, we're going to convert. We're going to start with 256 codes. And we're going to convert this into a number of seconds, because I just figured out that I can test one code every 10 seconds. I can test one code every 10 seconds. Now you might ask yourself, why did you write it this way? Why didn't you write it this way? Here's the math. I want to get rid of codes and change it into time. And this is the conversion fraction that allows me to do that, because every 10 seconds is equivalent to one of the codes I need to check. Now, mathematically, if you've had me in Math 98 and 58, you've seen this before, but mathematically, the code unit will then divide off, and you're left with just seconds. So this actually tells us it's going to take me 2,560 seconds to check all 256 codes. 2,560 seconds. Now, 2,560 seconds might sound like a weird, what is that exactly? Well, let's convert that. 2,560 seconds. Let's convert that to something that actually does make sense. So let's go to minutes. So I can multiply this by, in every 1 minute, there are 60 seconds. In every 1 minute, there are 60 seconds. And then I can divide off the seconds and be left with just minutes. And then I have to do a little bit of math here, which I cannot do in my head. I have to divide 2,560 times 1 divided by 60. I'm not even going to, I can get it close, but I want to get it more precise for you. 2,560 divided by 60, it's going to be close to 142, about 43 minutes. So it would take us, me, Sean the computer, if I'm able to check 10 seconds, every code takes me 10 seconds, then it takes me 2,560 seconds to check all the code. So that's the worst case scenario if I had to check all 256. That I can then convert to minutes, and it's going to take about 43 minutes. So this is a very slow computer. This guy, very slow computer. Every 10 seconds checking a code. Modern supercomputers can check hundreds of millions, if not billions of codes every second. In other words, they'd be done immediately with 8-bit. But even with me being my slow self, 256 codes only takes 43 minutes to crack, and I could figure out whatever information was hidden in that 8-bit code. So that's why 8 bits is not enough. It's just not secure enough because brute force can get it pretty quickly. All right, we'll do 16-bit next. We'll take a look at that, and then we'll come back out here to the garage and we'll do some more math on 16.